Hello everyone. In this lecture, we will talk about the biased positive clipper. So basically, we will discuss the types and then specifically about the biased positive clipper. The types we can say first of all that we have already seen in the past that the clipper may be made up of diode in series or in parallel. Based upon that, we define the clipper as series clipper or we define it as shunt clipper. We have further classified based upon the requirement of wave shape, and we have said that it may be series, shunt, or it may be biased. That is what we are going to discuss in this lecture. And another term we have said the positive clipper and negative, it is in all the cases whether it is series, it is shunt, or in biased form. Basically, we say that positive clipper is that which cuts the positive portion of the wave. If this is the wave, then the corresponding output will be such that the positive portion will be clipped. This is called as positive clipper. But that is what we have already done in series clipper and in shunt clipper. Now the question is that if this is our input wave V in and we want to cut only the some portion of the positive half cycle, not the complete one. For example, we want that negative cycle will be as it is, but positive half cycle, let us say only this much portion should be passed and then it should stop like this. Again, in the same manner like this. So we want that the upper half portion is, we are saying that this must be cut, while the remaining portion in the positive half cycle, this one must be there. So what we say that we only want to cut some portion of the wave in the positive half cycle. So it is still positive clipper. But to cut only the some portion from the complete positive cycle, we need to have a battery in addition to the diode in the circuit. So that with the help of this battery, we can bias this diode in such a manner that it can pass the signal only for the required range and can clip for the desired range. So let us come to the point of biased positive clipper. So as the name is indicating that positive clipper, that means cutting the positive, some portion of the positive half cycle since it is biased. Okay, so starting from the previous case that we have discussed, the series clipper where the diode is in series arm, or the shunt clipper where the diode was in shunt arm. So in this case, when we are biasing it, we can make it either with the help of this diode, this series clipper, or with the help of shunt clipper. Anyone can be used, right? Whether we are using diode in series arm, we can place a battery here either in this direction or in opposite direction, and we can also use the shunt clipper. So let us take the example of shunt clipper to make biased positive clipper. Again, we would like to say that positive clipper as well as negative clipper both are there, and we are providing a biasing. So if I say that I want to cut only the positive portion by positive clipper. Okay, so for that, if I recall the previous point that this was the circuit of which type of clipper, means whether it is positive clipper or negative clipper, because we have to add on, we have to first make the positive clipper. Okay, no problem, rewriting. We have to first make the positive clipper, and then from that positive clipper we have to provide some biasing to make it bias positive clipper so that some portion of the positive half cycle can be cut, right? So first of all, recheck that whether this is biased, this is positive clipper or negative clipper. So recalling the previous thing, that if the cycle of the input wave is positive half, then this is positive, this is negative, and in that case this diode gets short circuited and the output is 0. So it ensures that for the positive half cycle the output is 0, and for the negative half cycle the diode will become open circuit, and for that case the output will flow in this manner if we have connected a resistance RL here such that we have already said in the past that RL is much higher in comparison to R. So in that case, the output will be same as input. So this is just recalling of the previous point that this was our positive clipper. But what we want now is not to remove the complete positive half cycle, but only some of the portion. So we have to connect a battery. Now, what are the ways that we can connect the battery in series with the diode in two manners? We have this diode, we have this resistance RL, we have this resistance R. Here also, this is our circuit. I am drawing the two different cases of the connection for the battery. Here what we can do that we can place a battery here such that the positive terminal is this one and negative terminal is this one, or just opposite that the negative terminal is this one and positive terminal is this one. So both the cases are possible. This is your V in and you will get V output here. Either this case or this one, V out here and V in here, this case. So we have two cases, that is either the battery is connected in this manner or the battery is connected in this manner. So what will be the effect? We will discuss one by one. Let us first take the first half portion, this one. So taking this portion, again we are saying we are going to analyze this case that when the diode is connected with the battery in the manner that this N terminal of diode, this is N, this is P, is connected to the positive terminal of the battery. Let us say this is having some voltage V. For understanding, let us take some value. Let us say V is equal to 2 volt. And let us say we are applying an input voltage, the sinusoidal input signal of peak magnitude plus minus 5 volt. Then here we are having one resistance RL and we connect it here. V in is applied here and we are taking output here. Now to analyze this case, that how much will be the output, we have to assume some values of R and RL also, and just to neglect the condition, we have just assumed that RL is much higher in comparison to R, right? Otherwise we have to calculate by RL upon R plus RL using simple resistive divider network rule. So first case we will analyze here for the positive half cycle of the input signal. Positive half cycle of the input signal. It is totally same what we are doing as we have done in the past. We will analyze for positive half cycle as well as we will analyze for the negative half cycle of input signal. So first case we will analyze is for positive half cycle of the input signal. That means redrawing the circuit, R, RL, V out and V in. Positive half cycle means this terminal is positive and this terminal is negative. Now here is diode is connected where P is this one and N is this one, and a battery is connected here. This battery is of 2 volt and V in is having a peak magnitude of 5 volt. Right? Now let us see that the N terminal of the diode is connected with the positive terminal of 2 volt. That means this diode is reverse biased. N terminal is connected with the positive terminal of the battery. So this diode is reverse biased with a potential of 2 volt. So if this is a positive half cycle of the input signal, the positive potential will appear here. But until unless this potential is increasing from 0 to 5 volt and until unless this potential reaches to 2 volt, the potential at the P terminal is less in comparison to the potential at N terminal, which is already having minus 2 volt. So that is why we say that from 0 to 2 volt of V in, diode is diode is reverse biased. And diode is reverse biased means that this portion, let me change the color of the ink, red. Okay, so we are saying that for this case, when until unless it is 0 to 2 volt, in that case this diode will be reverse bias, and if it is reverse bias it is open circuit, so we have only this portion here to conduct. So output voltage will conduct via R and RL, and V output will be RL upon R plus RL into V in, and we have already said that RL is much higher than R, so it will be nearly equal to V, right? So this is the case until unless the input voltage reaches from 0 to 2 volt. And from 2 to 5 volt, what will happen? When when the input voltage is greater than 2 volt, that means 2 to 5 volt, what will happen? At the P terminal, the potential is 2.1, 2.2 up to 5 volt, and here the battery is making it minus 2 volt. So overall, this diode will become forward bias, and hence it will conduct. And if it will conduct, then in that case, we can say the circuit will reduce in which form? Here is your resistance R, the diode is conducting, so it is short circuited, and here is a battery of 2 volt, and here is your input voltage, and this input voltage is between 2 to 5 volt. In that case, here across RL, where we are taking V out, we can see that this 2 volt battery is in parallel to this RL. That means V out. So V output will stuck to 2 volt. That means V out is equal to 2 volt. So we can draw this here. We can say that output will be such that when input is changing from 0 to 5, in output V out will change from 0 to 2, 2 to 5. 0 to 2 volt, it will increase as it is, right? From this formula, we can say this, that it will follow the input voltage. But from 2 to 5, it will stuck to this value as 2 volt. And then again, 5 to 2, it will come back and it will follow the input waveform. Then let us talk about the negative half cycle. So let me again change the ink. So for the negative half cycle, we will again redraw the circuit. We will say that B in is applied between these two terminals. R is connected here. Here we have diode and battery, P and N regions. Here we have RL, across which we are taking output V out. Now V in is in the negative half cycle. That means this is the negative terminal and this is the positive terminal. So what will happen? N is connected already to a 2 volt battery, that means reverse bias, and more positive potential is coming at this terminal, that means diode will remain reverse bias, though, so the diode will remain open circuit. And if diode will remain open circuit, that means that will not come into the picture, and hence we will say that the reduced circuit will be, we can redraw that or we can remove this. We can say that the reduced circuit will be simply R, RL, V in with this terminal negative, this terminal positive, R, RL, and here we are getting the output. So that means again, as we do in this case, that means V output will be nearly equal to V in. So that means output will follow the input completely in the negative half cycle. That means it will be something like this one. So finally, we conclude that for this circuit, I am drawing the circuit again, that for this circuit, when the diode negative terminal is connected to the positive terminal and RL is connected here, and we are taking the output, for this case, the output voltage, let me draw the both the waveforms. If this is your input waveform, V in, like this, a sinusoidal wave, then the output waveform will follow the input waveform for two cases. One is when input is having a negative half cycle, and for positive half cycle when the input is less than the battery potential, right? So if I have taken this battery potential as 2 volt and input as plus minus 5 volt, then I can say that output voltage will follow the input voltage for the negative half cycle completely, while for positive half cycle it will follow up to 2 volt only, and then it will stuck at this value like this, and upper portion we will not get. So that is what we call it positive biased clipper, because it is clipping the positive portion but only some portion of the positive wave, not the complete. Similarly, we can analyze another case. If we connect the battery in reverse manner, what will happen and which portion it will cut. In that case, it will not be the positive bias clipper, but instead it will become negative bias clipper. That is why we are not discussing that portion in this lecture. We may discuss it in the next lecture. This is all about this portion. Thank you.